Mind-blowing recent and future advancements of forensic science.
Do you know that forensic science wasn't invented by scientists?
They were invented by cops who relied heavily on observation and common sense. Police officers using fingerprints to identify culprits led to forensic science as we know it today. Source: Forensic Science Online. Forensic science is a critical element of criminal justice system. Forensic scientists examine and analyze evidence from crime scenes and elsewhere to develop objective findings that can assist in the investigation and prosecution of perpetrators of crime or absolve an innocent person from suspicion. Source: Office of Legal Policy, U.S. Department of Justice. Forensic science is a multidisciplinary field that applies scientific principles and techniques to investigate crimes and analyze evidence. Welcome to Real World Sci-Communications. If you are new to this channel, kindly give us a like, make some comments, subscribe, hit the notification bell, and share. And to our returning subscribers, thank you for believing in us. In recent years, there have been several mind-blowing advancements in forensic science, driven by technological innovations and breakthroughs in various scientific disciplines. These advancements have greatly enhanced the accuracy, efficiency, and scope of forensic investigations. According to Open Access Government, there are 4 latest breakthroughs in forensic science, which include: number 1, preserving bone proteins. Bone holds a reservoir of information that can be key in forensic investigations. They give investigators better insight. Number 2, a simpler way to view fingerprints using nanotechnology. Number 3, the true power of proteomes. Forensic scientists are now turning their attention to proteins in bone, blood, and other biological samples, which can sometimes answer questions that DNA can't. Number 4, handheld devices to instantly detect compounds, for example, cocaine and explosives. Source: openaccessgovernment.com. To this day, forensic science has witnessed a number of significant advancements, from high-tech tools to DNA profiling and cyber forensics. Forensic investigation are a lot easier now than it ever was. DNA profiling has in fact led to the successful identification of numerous criminals across the globe. Source: eflab.org. Aside of forensic science experts which specialize in the scientific techniques and methodologies using crime scene investigation, evidence analysis, and forensic laboratory work, there are also technology and innovation experts which focus on the latest technological advancement and innovations that are being applied to forensic science, such as DNA analysis, fingerprint identification, digital forensics, and advanced imaging techniques. There are also legal experts. These experts have a deep understanding of the legal aspect of forensic science, including the admissibility of evidence in court, expert testimony, and the impact of new advancements on legal proceedings. Now let's talk about 10 mind-blowing recent and promising future advances in the field of forensic science. Number 1, forensic molecular biology, or DNA analytical science. It has been one of the most significant advancements in forensic science. It has revolutionized criminal investigations by providing accurate identification and linking suspects to crime scenes, by the ability to extract and analyze DNA from biological samples. Techniques such as polymerase chain reaction (PCR) and short tandem repeat (STR) analysis have made it possible to identify individuals with high levels of accuracy using trace amount of DNA evidence. There are advancements in DNA phenotyping which predict physical appearance traits from DNA samples. The development of rapid DNA analysis systems allows for on-site testing and real-time identification of suspects. The use of touch DNA is one notable advancement in DNA analysis. Touch DNA refers to the small amount of DNA left behind when an individual touches an object. With improved sensitivity and techniques, forensic scientists can now analyze touch DNA from surfaces previously considered unsuitable for testing. This breakthrough has helped solve cases where traditional DNA sources were unavailable. Another exciting development are emerging technologies like next-generation sequencing (NGS), which enable more comprehensive DNA profiling from degraded or mixed samples. NGS allows for the simultaneous analysis of multiple genetic markers, providing more detailed information about an individual's genetic profile. This advancement has increased the discriminatory power of DNA analysis, making it even more reliable for identification purposes. Number 2, forensic toxicology. Forensic toxicology involves the analysis of drugs, poisons, and other substances in biological samples to determine their presence and concentration. Recent advancements in this field have expanded the range of detectable substances and improved analytical techniques. A significant advancement is the use of liquid chromatography mass spectrometry, LC-MS, for drug analysis. LC-MS offers high sensitivity and selectivity, allowing for the detection and identification of a wide range of drugs and their metabolites in complex biological matrices. This technique has greatly enhanced the ability to detect new psychoactive substances and designer drugs, which pose challenges for traditional screening methods. Emerging technologies like high-resolution mass spectrometry also offer enhanced capabilities for identifying new psychoactive substances and designer drugs. Additionally, advancements in hair analysis have provided valuable insight into long-term drug use. Hair can retain a record of drug exposure over extended periods, offering a more comprehensive timeline compared to other biological samples. Improved extraction and analytical techniques have made it possible to detect and quantify a wider range of drugs in hair samples, providing valuable evidence in cases involving drug-facilitated crimes or chronic drug abuse. Number 3, digital forensics. With the increasing reliance on digital devices in everyday life, digital forensics has become a crucial field within forensic science, a critical aspect of modern investigations. Advancements in this field encompass the recovery and analysis of data from computers, smartphones, cloud storage, social media platforms, and other digital sources. Techniques like computer forensics, mobile device forensics, network forensics, and data carving have been developed to extract valuable evidence from digital devices, aiding in the investigation of cybercrimes, fraud, and other digital offenses. The implication of this is that data can be recovered and decryption methods employed to retrieve information from any digital media source, whether encrypted or damaged. Number 4, forensic entomology. It utilizes the study of insects and their life cycles to estimate the time of death and assist in criminal investigations. It involves the study of insects associated with decomposing bodies to estimate the time of death or post-mortem interval. Recent advancements in this field include the use of DNA analysis to identify insect species and determine their geographic origins. Additionally, the information can help establish a timeline for decomposition and provide additional evidence for investigations. Forensic research has focused on developing more accurate models for estimating the post-mortem interval based on insect colonization patterns and environmental factors. Additionally, advancements in chemical analysis techniques have improved the ability to detect toxins or drugs present in insect samples. Gas chromatography mass spectrometry (GCMS) and liquid chromatography tandem mass spectrometry (LC-MS) are commonly used to analyze insect evidence for the presence of substances such as drugs, pesticides, or poisons. These techniques have enhanced the accuracy of toxicological assessment in forensic entomology. Number 5, forensic anthropology. Forensic anthropology combines principles of anthropology with forensic science to analyze human remains. It plays a vital role in identifying human remains and reconstructing events surrounding a crime. It involves the analysis of human remains to determine factors such as age, sex, ancestry, and cause of death. One notable advancement is the use of 3D imaging technologies for virtual autopsy. Virtual autopsy, also known as postmortem computed tomography (PMCT), involves scanning the body using computed tomography (CT) or magnetic resonance imaging (MRI) to create detailed 3D models. These models can be examined from various angles and manipulated to reveal hidden injuries or anatomical features. Virtual autopsies are non-invasive and can provide valuable information without the need for traditional autopsy in certain cases. These models can be used for facial reconstruction, age estimation, and trauma analysis, providing valuable insight for forensic investigations. Laser scanning can also be used alongside CT to create detailed virtual models of skeletal remains. And these models facilitate accurate measurement, reconstructions, and comparison with databases for identification purposes. Another exciting development is the use of stable isotope analysis in forensic anthropology. Stable isotopes are naturally occurring variation of elements that can provide information about an individual's diet, geographic origin, and movement patterns. By analyzing stable isotopes present in bone or tooth samples, forensic anthropologists can gain insight into an individual's life history and familial relationships, helping to establish identity or reconstruct events leading to death. Thank you for listening.